Think about the last time you checked your email, streamed a movie, or collaborated on a document with someone across the country. None of those things happened on your computer. Not really, they happened in the cloud. But what does that actually mean? And why did virtually every company on Earth decide to move their operations online over the past 15 years? Today, we're breaking down cloud computing, what it is, how it works, and why it fundamentally changed the way technology gets built and delivered. We'll look at real examples, bust some common myths, and help you understand why this shift matters, whether you're building the next big startup or just trying to make sense of where your data actually lives. Let's start with the basics. At its core, cloud computing is surprisingly simple. It's using someone else's computers over the internet instead of running everything on your own hardware. But to understand why that's revolutionary, we need to go back to how things used to work. For decades, if you wanted to run a website, an application, or store data, you had two options. Either you bought physical servers, stuck them in your office, and managed everything yourself, or you rented space in a data center where you'd install your own equipment. Either way, you owned the hardware, you managed it, and you paid for it whether you were using it or not. This is called on-premises infrastructure, or on-prem for short. The problem? It's incredibly inflexible. If your website suddenly gets popular, you can't just instantly add more servers. You have to order hardware, wait for delivery, install it, configure it. Now that takes weeks or months. And if traffic drops, you're stuck with expensive equipment sitting idle. Cloud computing flips this model entirely. Instead of owning servers, you rent computing power by the hour, or even by the second. Need more capacity? Spin up new virtual servers in minutes. Don't need it anymore? Shut it down and stop paying. This is possible because of virtualization, a technology that's been around since the 1960s but became practical and widespread in the 2000s. Virtualization lets one physical server pretend to be dozens or even hundreds of separate computers. Each virtual machine acts like its own independent server, but they're all running on shared hardware in a massive data center. The big cloud providers, Amazon Web Services, Microsoft Azure, and Google Cloud, often called the hyperscalers, run millions of these physical servers in data centers around the world. They handle all the complexity, power, cooling, security, hardware failures, network connectivity. You just use what you need. Now, cloud computing isn't just one thing. It comes in different flavors, depending on how much control you want versus how much you want the provider to manage for you. The first is Infrastructure as a Service, or IaaS. This is the most basic level. You're essentially renting virtual servers, storage, and networking. You still have to install your own operating system, manage security patches, and handle everything on top of that. But you don't own the physical hardware. AWS EC2, Azure Virtual Machines, and Google Compute Engine are all examples of IaaS. Next is Platform as a Service, or PaaS. Here, the cloud provider manages the infrastructure and the operating system. You just focus on your application code. Services like Google App Engine or Azure App Service handle scaling, patching, and most of the underlying complexity. You write code, you deploy it, and it runs. Finally, there's Software as a Service, or SaaS. This is what most people use: Gmail, Salesforce, Dropbox, and Zoom. You're not managing infrastructure or code. You're just using a fully built application over the internet. The provider handles absolutely everything behind the scenes. So why did this model take over? Let's talk about the key advantages that drove this massive migration. The first argument would be elasticity. This is the ability to scale up or down based on actual demand automatically. Imagine you run an e-commerce site. On a normal day, you might need 10 servers to handle traffic, but during Black Friday, you might need 200. With on-prem infrastructure, you have to buy for your peak capacity and leave those servers mostly idle for the rest of the year. With the cloud, you scale up for the holiday rush, then you can scale back down. You pay for what you use when you use it. Second, it's all about speed. In the old world, provisioning new infrastructure could take months. You'd submit a request, wait for budget approval, order equipment, install it, configure it. With cloud computing, a developer can spin up a new environment in minutes. This acceleration enables rapid experimentation, faster product launches, and quicker responses to market opportunities. Third, managed services. Modern cloud providers offer hundreds of specialized services, databases, machine learning tools, analytics engines, security services, all fully managed. Instead of hiring experts to run and maintain each of these systems, you use a service where the provider handles operations, backups, scaling, and even updates. Your team focuses on building products, not maintaining infrastructure. Fourth, global reach. The hyperscalers operate data centers on every continent. If you want to serve customers in Tokyo, Sao Paulo, and Frankfurt with low latency, you can deploy your application in multiple regions with just a few clicks. Building your own global infrastructure would cost tens of millions and take years. But there's an important concept to understand here: the shared responsibility model. When you move to the cloud, security and operations become shared between you and the provider. The cloud provider is responsible for securing the physical infrastructure, the buildings, the hardware, the networks between their data centers, but you're still responsible for securing your data. data, managing who has access to your resources, configuring your applications properly, and ensuring your code doesn't have any vulnerabilities. Now, the cloud gives you tools, but it doesn't make security automatic. Now, this brings us to FinOps, financial operations for the cloud. Because cloud billing is based on usage, and there are thousands of different services with complex pricing, costs can spiral out of control if you're not careful. A forgotten test environment running for months, over-provisioned databases, inefficient code that wastes compute resources. All of this shows up on your bill. Smart companies build teams and processes specifically to optimize cloud spending, monitor usage, and ensure that they're getting value for money. Let's look at how this plays out in practice with 3 different scenarios. Imagine a small team launching a new mobile app. 10 years ago, they'd need significant upfront capital, buy servers, set up networking, hire operations staff, hundreds of thousands of dollars before a single customer signed up. Today, they start with AWS free tier or minimal Azure spend. They build their app using managed databases and serverless functions. If the app fails, they've spent almost nothing. If it succeeds and suddenly gets 1 million users, the infrastructure scales automatically. This dramatically lowers the barrier to entry for new companies. You can start small, validate your idea, and grow infrastructure in lockstep with revenue. Consider a video streaming service that starts in the United States. Now they want to expand to Asia and Europe. With on-prem infrastructure, they'd need to establish data centers in each region, negotiate with local providers, hire staff on the ground, and invest millions before serving a single international customer. With cloud computing, they deploy their application to AWS regions in Singapore, Mumbai, Frankfurt, and London in a matter of days. Content delivery networks automatically cache videos closer to users. The experience is fast, and they pay only for actual usage in each region. If one market grows faster than expected, capacity scales automatically. If another market underperforms, they're not stuck with expensive idle infrastructure. A retail company has years of transaction data sitting in databases. They want to analyze customer behavior, predict trends, and optimize inventory. Building a traditional data warehouse with enough computing power for complex analytics would require specialized hardware and a team of database administrators. Instead, they move their data to Google BigQuery or Amazon Redshift, managed analytics services. They run queries against billions of rows of data, and the service automatically distributes the work across thousands of machines. They pay per query, not for idle infrastructure. Data scientists can focus on insights rather than managing servers. The company can experiment with machine learning models using pre-built services without becoming experts in distributed computing. Now let's address 3 myths that you'll hear about cloud computing, things people believe that aren't quite right. This is probably the biggest misconception. Cloud can be cheaper, but it's not guaranteed. For predictable, steady workloads that run constantly, owning your own infrastructure can actually be less expensive long-term. Where cloud wins is on flexibility and variable workloads. Now, if your traffic is unpredictable, if you need to scale rapidly, or if you want to avoid upfront capital expenditure, cloud makes economic sense. But if you're running the same database workload 24/7 for years, and you have the expertise to manage it, buying your own servers might actually cost less. The key is matching your cost model to your workload pattern. Many companies use a hybrid approach, stable workloads on-prem or on reserved cloud instances with steep discounts, and variable workloads on elastic cloud services. Cloud providers offer impressive reliability, often measured in 9s of uptime, but nothing is bulletproof. Amazon, Microsoft, and Google have all experienced major outages that took down large portions of the internet. The shared responsibility model applies here too. The cloud provider is responsible for their infrastructure, but you're responsible for architecting your application to handle failures. If you run everything in a single data center and that center goes down, your application goes down. True resilience requires designing your systems to spread across multiple availability zones or regions and to gracefully handle partial failures. Cloud gives you the tools to build highly available systems, but building for reliability requires expertise and often additional cost. Redundancy isn't free. And when people say the cloud, they're usually oversimplifying. AWS alone offers over 200 different services. Some are compute, some are storage, some are specialized for machine learning or IoT or media processing. Microsoft Azure and Google Cloud each have their own massive catalogs. Beyond the hyperscalers, there are hundreds of other cloud services, specialized hosting providers, database companies that offer managed services, security vendors that operate in the cloud. The cloud is really a collection of different approaches, technologies, and providers. Even within a single company, you might use multiple clouds, maybe AWS for computation, Google Cloud for analytics, and Salesforce for customer relationship management. This multi-cloud approach provides flexibility, but also adds complexity. So why does all of this matter? Cloud computing fundamentally changed who can build technology and how quickly innovation can happen. It democratized access to sophisticated infrastructure. A college student with an idea and a credit card can access the same computing power that would have required millions of dollars just 2 decades ago. This shift enabled the explosion of startups we've seen over the past 15 years. It allowed companies to experiment more, to fail faster, and scale successful ideas globally without massive capital requirements. It also changed the job market. Roles like cloud architect, DevOps engineer, and site reliability engineer didn't really exist 20 years ago. Now, they're central to how modern organizations operate. But with these benefits come some new challenges. Cloud complexity requires new skills. Organizations struggle with cost management. Data sovereignty and privacy regulations complicate global deployments. Lock-in to specific cloud providers can limit future flexibility. Technology continues to evolve. We're seeing new models like serverless computing, where you don't even think about servers. You just run functions in response to events. Edge computing is bringing cloud capabilities closer to users and devices, and there's ongoing debate about the environmental impact of massive data centers, with providers racing to power them with renewable energy. Cloud computing isn't just a technology shift, it's an economic and organizational transformation. It changed how companies allocate capital, how developers build products, and how quickly ideas can go from concept to global scale. Understanding the cloud means understanding modern technology infrastructure. Whether you're making business decisions, building a career in tech, or just curious about where your data actually lives, knowing the fundamentals of IaaS, PaaS, and SaaS, understanding the trade-offs between flexibility and cost, and recognizing that the cloud is really just other people's computers, managed at massive scale, gives you insight into how the digital world actually works. The move online wasn't inevitable, but it was logical. As technology advances and new models emerge, the core principle remains: abstract away complexity, pay for what you use, and focus resources on what makes your product or service unique. Now, if you want to keep learning about technology and innovation, how new models emerge, why certain technologies win, and what's coming next, there are excellent resources available to dive deeper into these topics. The technology landscape keeps evolving, and understanding these foundations helps you make sense of whatever comes next.